Hello everyone, this is Monica and welcome to VLSICareerCraft. Today we are here to discuss an important topic in static timing analysis, that is, why does actually a setup or hold time exist in a flip-flop and what actually is a clock to queue delay in a flip-flop. Often we talk about setup violation, hold violation and how to fix this violation, but it is really important to understand why do they exist in a flip-flop. So let's get started. So starting with the flip-flop's internal operation, this is the internal structure of a D flip-flop. This is a master-slave configuration, and negative latch connected to positive latch gives us a positive edge triggered D flip-flop. So here we have transmission gates which acts as switches, and the inverters which are connected back to back are used as a storage elements. So the operation of D flip-flop is like this. When the clock is in rising edge, if the D is 0, then it stores 0. And if D is 1, then it stores 1. But if clock is not rising, then whatever D might be, it remains in the previous stage. So there is no change. So initially before clock arrives, that is when the clock is 0, the transmission gates which are driven by clock bar are turned on. That is the transmission gate over here and here are turned on. So they are short circuit, and the transmission gates which are driven by clock are open circuit because clock is 0. So the here and here it is a open circuit. So here the input goes through the node A, B, C and D, and then it waits for the clock to arrive. So after the clock arrives, that is when the clock equal to 1, the transmission gates which are driven by clock are short circuited and clock bar are open circuited. So here the data at node B passes to E and then F and it goes to the output. So this is a uh, brief overview of how the flip-flop operates. Now let's consider a scenario to understand the setup violation of flip-flop. Let's say the flip-flop is storing logic 0. So at D, input is logic 0 and the output of this inverter gives us 1 at node B, and this goes to the second inverter at node C, it is 1, and this gives us 0 at node D, and then it waits for the clock to arrive. Now let's say a new data arrives at D, that is logic 1. So the values at node A, B and C are overwritten by the new value, and let's say D is unchanged. So before the value at D changes, let's say the clock is arriving and the transmission gates which are driven by clock are turned on, and transmission gates which are driven by clock bar are turned off. So now let's see what is happening here. So in the node A, B and C are having new data and D is having old data. So D is forcing a value of 0 over node A, and A is forcing the new value which is 1. So therefore there will be a conflict at all the nodes, and we see all the nodes go into a state which is neither 0 nor 1, and it is termed as a metastable state. So after staying in the metastable state for some time, there will be a compromise between old and new data, and the flip-flop will leave the metastable state and come to either 0 or 1, and that is unpredictable. So how do we avoid metastability state in the previous scenario? If we don't want a conflict between new data and old data, we need to allow the enough time for the input to propagate into the internal nodes, that is A, B, C and D, before the clock edge arrives. So we can term setup time like this. The data must arrive certain time before the clock edge arrives so that the internal nodes A, B, C and D gets overwritten. So in the previous scenario, we have understood how setup violation occurs in a flip-flop and what is the setup time. Now let's get into hold time violation. Let's consider another scenario where the flip-flop is storing logic 0, that is The input is 0, so A is 0, B is 1, and which is connected to the second inverter, which gives C1, and D will be 0. And it awaits for the clock edge to arrive. Now let's say new data arrives at D, that is 1, which overrides the values at A, B, C, and D nodes to opposite values. Now what happens when the clock edge arrives? The transmission gates won't react instantly. Like it takes some time to get open circuited or short circuited. So in this case, the transmission gates in red are trying to get open circuited, and the transmission gates in green are trying to get short circuited. Now let's say the new data arrives before the red transmission gate completely opens. So what will D do? It forces the new value and new opposite value onto the node A, which in turn forces the internal nodes B, C, and D to the opposite values. So in this case, the flip-flop again goes into the metastable state where the nodes, the values at the node internal nodes are neither 0 nor 1. Similar to the previous scenario, after some time there will be a compromise between old data and new data, and flip-flop will leave metastable state and come to either 0 or 1, but that is unpredictable. So in this scenario, how do we actually avoid metastability state? So here we need to give certain time for the transmission gates to open circuit or short circuit, so that the internal nodes of the flip-flop are not overwritten by the new value. So we can define hold time like this. Data must be constant at D for some time after clock edge arrives to give time for the transmission gate at D to be open circuited. So till now we have understood what is setup time and what is hold time, and how does metastability state arises in flip-flop if there is a setup or hold violation. So coming to clock to Q delay in a flip-flop. What is a clock to Q delay? So going back to the operation of the D flip-flop, when the input D value at input D propagates to internal nodes A, B, C, and D, and then waits for the clock edge to arrive. After clock edge arrives, the transmission gate switches to the opposite positions, and then the value at B propagates to E and then F. So the output value is nothing but the value at node F. So the data passed through B, E, and F takes some time, and this delay is termed as clock to Q delay. So thanks for watching. I hope you all understood the concept of setup time, hold time, and clock to queue delays. Please follow us for more content and subscribe to our channel. Thanks for watching once again.